No, it's me being recorded so that if you guys ever want to, review something, you can go back on YouTube in the Google Classroom and check it out. Yeah, I posted on YouTube, yeah. Yeah, don't forget to like and subscribe and smash that like button, whatever kind of thing. So it's Mr. Widmeyer, and it's just these videos. How many viewers do I have? I think I have like 30 or 40 maybe. And I'm pretty sure they're like bots. Maybe. Probably not though. Okay. Like I said, like 30 to 50 or something like that. It's nothing. But my purpose is not that. My purpose is so that you guys can review. Okay?
Is there a space in between Mr. and Widmeyer?
I don't think so. Might be. Anyway. More importantly here, we want to write a function from this, right? Okay? So, this is like, they make it so complicated here. Let's just make it easy. So, f of x, the amount of money she earned is just 5 times x. That's it. Okay? That's the function. Okay? That's the function. Very similar to an equation. All right? Let's skip to another situation. A lawyer's fee is $180 per hour for his services. How much does the lawyer charge for 5 hours? Now look, guys, I know that you know what to do here. If the lawyer's fee is $180 per hour, and we want to know how much he'll charge for 5 hours, what should we do here?
Multiply 5 by 1.
Yeah, multiply, right? But the directions don't say just give the answer. The directions say identify the independent and dependent variables, write an equation in function notation for each situation, then use it to solve the problem. Okay? So, what is independent and what's dependent here? Okay? What depends on what else here? What's the sentence we could say here? What depends on what here in this situation? A lawyer's fee is $180 per hour for his services. How much does a lawyer charge for 5 hours? So let's go to Matt. What do you say? Okay, so the fee depends on the hours that he works. Okay, so and it says it right here: dependent, fee, independent, hours. Okay. So for the independent variable, that's going to be our variable here. And you can see they write it out for us. Just like Dylan said, take the amount of money he earns, multiply it by hours. So there's our function, f of h equals 180 times h. If we want to then figure out how much he should charge for 5 hours, what should we do with that 5 in this function? Substitute 5 for h. Exactly right. So f of 5 equals 180 times 5, which is $900. Wouldn't you like to be a lawyer? Yeah. Work 5 hours and make $900. Okay. Well, if you keep doing your algebra, maybe you can become a lawyer. Actually, you don't really need algebra, I think, to be a lawyer. Maybe. I don't know. Yes, and see what your parents think about that, okay? All right, letter B, next one. Admission fee at a carnival is $9. Each ride costs $1.75. How much does it cost to go to the carnival and then go on 12 rides? So hang on, I'm not interested. So what is the dependent variable here? What's the independent variable? What depends on what here? Okay, so think about that for a second. You go to a carnival for $9, and then it costs $1.75 per ride. How much does it cost in total to go to the carnival and go on 12 rides? So what depends on what here? Let's go to Ben. You have an idea here?
For what?
In this situation, okay, what depends on what in this case?
For B.
For letter B,
Okay. I got it. The price of the rides depends on how many rides you go on.
Yes. I'm going to say the cost, but that's great. Yes, the cost depends on the number, I'm going to use pound sign, number of rides. Okay? So, if the cost depends on the number of rides, what is the dependent variable, Sean? If the cost depends on the number of rides, which one of these two is the dependent variable? What's depending? The cost. cost is the dependent variable, and then what would be the independent variable?
Number of rides.
Yeah, number of rides. Okay, so now we're going to write a function for this situation. It costs $9 to get in and an additional $1.75 per ride. Okay, so how will we represent that? Reagan, do you have an idea? Your number came up here. It costs $9 to get in, so we're going to have to put down a 9. And then we also have to say it's going to be plus $1.75 per ride. So how can I show that?
Plus $1.75.
175. And do we know how many rides we're going to ride?
No.
Yeah, we're eventually going to do 12, but let's just do it generically though, and I'll just put an X there for the number we don't know. Okay, and then there's our function. Okay, that's our function. $9 for the ride plus $1.75 times the number of rides equals our cost function there. Okay, and then if I want to know how much it's going to cost for 12 rides, what should I do with that 12? Mark. So there's my cost function, and I want to know how much does it cost to go on 12 rides. What should I do with that 12 within my function here?
Switch it out with the x's.
Yeah, plug 12 in. So we'll say f of 12 equals 9 plus 1.75 times 12. Okay, I'll put in my calculator. We get $30. Okay, $30. So the cost is dependent on the number of rides. If you rode fewer rides, the cost would go down. If you rode more rides, the cost would go up. Okay? So the rides is what we're choosing, and then the cost is the kind of the result here. Okay? So I'd like you guys to go ahead here and try number 4. Don't just give me an answer. Identify the independent and dependent variables. Write an equation in function notation, then solve the problem. Okay, I know that you guys can look at this and give me what the answer is going to be. I want you to identify the independent variable, so I'm going to put an I for that. I want you to identify the dependent variable, a D for that, and then give me a function, f of x equals, and then fill in what the function is going to be there. Okay, go ahead and do that, please, real quick. Read the situation, what depends on what, and then go from there. Write the function, answer the question. Okay. So I'll give you like a minute or so here. Read it, answer the question. What's independent variable? What's dependent variable? Okay. If you're stuck or something, I'll come around and help. Oh, okay. I hope so, Sean. Show me that it's easy. Get it right and show me that it's easy. Okay, that is perfect. Identify what's in the what depends on what? Cost depends on. Hold on. You flip it around. Cost is one that depends, right? Cost depends on hours worked, right? So if you know what they're arguing, so we said 50 times that. Yeah. I'm not ready to say that just yet.
Okay,
Hold on for a
so
second.
basically,
Flip your independent pieces that, so it's the hours worked and the cost.
Oh my gosh. But it's equation, correct?
Yes, yes. The function was right. Good job.
Thank you.
Okay, that's good. Good job. So next is what? What's going to describe how much money this person earns? Well, what are they earning?
Come on, Liv, you got this.
I'm going to read this one right here. Per hour. So how would you write that? 750. Because no equals that's it. Now, how much will she make after working 8 hours? So now what do you do with that 8 in your function? What does x represent? Number of what? So what do you do with that 8? Substitute it. So f of 8, so f parentheses 8 equals the amount earned, and then the time. But you put like the specific values in. You're on the right track. Okay, nicely done. Nicely done. And then you'll just multiply it. Okay. I'm seeing some good things, folks. I'm seeing some good things. I know that independent, dependent stuff is a little bit tricky, but here we go. Sean, were you able to identify what depends on what in this scenario here? Cost depends on the number of hours worked. So that means the dependent, what is doing the depending? Cost. So dependent is cost. Okay, or earnings. You could also call it that, I would say, in this case, because she's kind of earning that money. Okay, and then independent would be the number of hours. Okay, she's kind of in charge, I guess, about whether she decides to do those or not. Okay, very good. And then let's go to Matt. Matt, were you able to come up with a function that describes this scenario? F of x equals? Oh, sorry, Matt S. Thank you. Okay, so she's earning $7.50 per hour. How can we write that? Okay, let's just do it more generically. So not 8, let's just say x. And that's it. Now, if she's going to work 8 hours, we'll say f of 8 equals 7.50 times 8. And we'll just multiply it out. $60. So you're on the right track there, Matt. I just want to make sure we could write the function first. That's all. Okay, questions on any of that? Feeling good? All right. I want to skip to the next page, page 130. We're going to look at the your turns there on 5 and 6, and we're going to discuss these as well. Okay? Because the top of this page, and these are the last 2 practice problems we'll do, and I'll get you started on the homework. The top of this page says choosing a reasonable domain and range. Now that we're talking about real life, right? Certain things will make sense, certain things will not make sense to have in our domain. If I go back here and talk about Kate and her working, would any number of hours make sense for her to work? Any number? No. Yeah, what would be some numbers that don't make sense for her to work? 24? 72? Right. I mean, at some point, like, you're not really babysitting anymore. You're now, like, raising the child, right? But 329, right, it's too much. What about, you guys are missing, what about negatives? Negative hours would make no sense. Now you're talking about like going back in time, right? You need a DeLorean to do that, okay? So, right, thank you, yes. So you can see at least what's the lowest number of hours that she could work? 0, I would say, but potentially 1, because like Mr. Wade, you said work. 0 would be not working. So I hear what you're saying there. But 0 or 1, something like that. And then the most, well, certainly there is an upper limit at some point, right? That's what we're... Right, exactly. And so then my point then also then, that would also affect the cost. What's the minimum amount of money that she could earn? She could earn $0, right? She's not going to earn negative dollars. So that's the point, is identifying what would make sense. What would make sense as a domain and a range, because not every one of these values makes sense. Also, we're going to have to think about, should our domain be discrete or should our domain be continuous, okay? Some babysitting jobs, you can do like fractions of an hour, but otherwise you probably just get paid for the nearest whole hour. In that case, if we're only getting paid for the nearest whole hour, would this be discrete or continuous? If we only get paid for the nearest whole hour, would that be discrete or continuous? It would be discrete, because either it's 1 hour you've worked, or it's 2, or it's 3. You're missing all those little fractions of an hour in between. So you could be discrete. There are situations, though, that could be continuous, I guess. Anyway, that's what I'm getting at here. So let's take a look at 5 and 6. We're going to write a function in function notation and then find a reasonable domain and range for each function. Okay, number 5 says, the temperature early in the morning is 17 degrees Celsius. Celsius, what is this? Some sort of communist, units of temperature here? We use Fahrenheit in America. America. But anyway, we're going to have to deal with degrees Celsius. Okay. So, the temperature increases by 2 degrees Celsius for every hour for the next 5 hours. Write a function for the temperature in degrees Celsius. Okay, so what will our function be? I'm just going to use, again, plain old f of x equals, And then how can we set up our function here? It starts at 17 degrees Celsius, and it increases by 2 degrees Celsius every hour for the next 5 hours.
17 plus 2x.
17 plus 2x, Carson, you nailed it. Okay? Now, all right, guys, thanks. I'll take care of that. All right. Just gets to be a little bit much, I think, sometimes. All right. What is a reasonable domain? What are reasonable x values for this particular problem? What's the lowest reasonable x value for this problem, Dylan? 0. Okay? And then what's the biggest reasonable x value for this problem, Alex? So,
Well, yeah, it's 2 times 17.
well, okay, I hear, but let's just think though, the temperature increases 2 degrees Celsius for every hour for the next 5 hours. So we don't know that it's going to follow any more beyond that. So what's the highest domain value we can get to? Probably 5, okay? So it means we're going to hit 0, 1, 2, 3, 4, and 5. Now, you might be like, Mr. Whitmire, time is continuous, right? But it is saying it rises by 2 degrees every hour. It's not really saying about like what's happening between. So I could see what you're saying. You could argue, if you wanted to, you could argue with me that it would be this. I kind of am okay with either one of these. Either make it discrete or continuous, your choice. Okay? Now, we found the reasonable domain, but what's a reasonable range? So, Matt?
Would it be the actual answer of the problem or no?
Okay, right. So, where do we know the temperature starts at what? 17, and it's going to increases. So, the range is going to start at 17, and it's going to increase, and then what will the highest temperature get to after those 5 hours?
I got 27.
It is 27. How'd you get 27?
I did the math.
Yeah, you use this uppermost domain value here, plug 5 in for the x. 2 times 5 is 10, plus 17 is 27. So the highest we're going to get is 27, and then again, that's degrees Fahrenheit. Understand that, okay? So that's actually pretty warm. Okay? Or again, I would also be okay if you said, 17, ... all the way up to 27, like you were going to list them out. Whoops, I need to use the brace there for that. But I'm guessing, again, we probably should use this one. I think this is what they really want, and they probably want us to use this one for the domain. Okay? Let's try the next one. Takumi earns $8.50 per hour proofreading advertisements at a local newspaper. He works no more than 5 hours a day. Write a function for the temperature in degrees Celsius. Guys, there's a typo there. That's a pretty massive typo in this book. It's talking about hours proofreading advertisements and working, right? And then it says, what's the temperature in degrees Celsius?
25.
Whoops. So, yeah. 3? No, this is wrong. But we can still write the function.
Foreign words.
You think so?
Yeah.
Like the Celsius, it gets everyone confused. Okay. What's our function here? Yeah, so Takumi earns $8.50 per hour proofreading advertisements at a local newspaper. He works no more than 5 hours a day. Write a function for this situation, right? So what's our function rule here? How do we figure out? So I'm going to go someone else, Matt, because I want to give everyone else an opportunity too here. Let's go to All right, Dylan. The function E is 850 x. And that's it. That's right. Okay? The x is representing a number of what? It's the time, right? So that's our independent variable. It's time. So what makes sense for our domain here? What's the least number of hours that he could work? 0. And what's the most number of hours that he could work? He works no more than 5 hours a day. And again, we have to kind of make an assumption here. Does he get paid like for fractions of an hour, or does he only get paid for each hour that he works?
Each hour.
You think each hour? All right, let's do that then. So brace then. 0, 1, 2, 3, 4, 5. Okay, for discrete. And then our range. Okay, well, what's the least amount of money he can make? 0, right? So again, for this one, I'm going to put 0. I'm going to use discrete as well. And then if he works 1 hour, he gets $8.50. If he works 2 hours, he gets twice $8.50, so that's going to be $17. If he works 3 hours, that's going to be $25.50. And then if he works 4 hours, yes, you got to keep going, $34. And if he works 5 hours, whew, we're done. But 5 hours would be $42.50, I think there. Yeah, Mr. We can do mental math. All right, so. Oh, sorry, I thought you needed something. You're just cheering me on. Okay, so there it is. So the rest of the time I'm going to give to you, I'd like you to work on this assignment, okay? Okay, here's what I'm going to assign. On page 131, I want you to do. Hang on a second, let me just check my math. Okay, I want you to do numbers 2 through 20 evens. 2 through 20 evens. Please make sure you read the directions and answer what's being asked. And number 2, it just says to it says to write a function there. Okay, I'll get you, Eric. I'll get you the rest here in a second. So 2 through 20, the evens, please. Okay, and please make sure you answer the questions. For 4 through 12, you need to identify independent and dependent, and then write a function and solve the problem. Okay. 14 and 16, you just need to write a function and then give the reasonable domain and range. Okay. Same thing for 18 and 20.
This is if we don't finish.
It'll be homework if you don't finish it. So, again, sorry. For 4, 6, 8, 10, 12, you're doing the independent, dependent, writing the function, solving the problem. Okay? For 14 through 20 evens, you're writing the function. You're not solving, though. You're just going to give me a reasonable domain and a reasonable range. For the scenario, yeah. But, of course, the reasonable range requires us to solve then. You got to match the domains and ranges. So, okay? Get started. I'll come around and help you. Okay, Ms. Mulcahy will too.
Mr. Whitmire,
Yes.
numbers,
Yes, let me just finish. Actually, okay. Answer your question first. Yes, Ms. Mulcahy, what's the question?
On number 6, could it also be a discrete function? I mean, discrete?
I would say it's probably discrete. Continuous?
Wait a second.
I would say they are discrete right now.
All right. For number 5, what was it?
Number 5, I would say in that case probably needs to be continuous. Because you think about the temperature has got to, if you're going to get from one temperature to another, you're not going to jump temperatures. You're going to have to go from all the ones in between.
Okay, thank you.
Yeah.
Thank you. I just had to think about it.
I know, it's subtle, and sometimes it's, you're like, do I need to think this much about it? But yeah, I think so sometimes.
Oh, boy.